Okay, so we are going to review how to find the line of best fit, or in some cases the curve of best fit, with a given data set. So you need to have your graphing calculator out with you now. I'm not going to be able to show you my graphing calculator screen, so do your best to follow along with the steps. If an error occurs, try to at least follow along with what I'm saying and doing, and then we'll fix all calculator issues tomorrow in class. Okay, so this is the data we're going to start with. Mr. Ha has asked students how much time they spent studying for the final exam in his class. Then he compared the number of hours that each student studied with the grade they earned in the test, on the test. Okay, so what you're going to do first is, this is statistical data, so we have to enter it in our calculators as statistical data, not like equations like we have been doing. So, turn on your calculator. I want you to hit second y equals, because that gives us our stat plot. And I want you to hit enter. We're going to go into the first one. Now, what I want you to do is I want you to make sure that it's on. We have to turn the plot on, or else we're not going to be able to plot a scatter plot on our calculators. So if on is not highlighted, turn it on now. The next thing we need to do is enter in our data. To do that, we have to enter it in our stat lists. So you are then going to hit the button stat and then hit enter, because we're going to edit the lists that we have. Now, make sure you're in L1, L2. If you don't see your L1, L2, meaning they're not there, you can't arrow over and find them, I want you to reset your calculator. To reset your calculator, you're going to hit second and then the plus sign for memory. Then I want you to hit number 7 for reset, and then number 1 for all RAM, and then reset it. Now, after you do this, you should then be able to go to Stat Edit and see L1, L2, L3, and there's probably 6 that you have. But what you're going to have to do again is go back into the stat plot and turn it on. Okay, so what you need to do is enter in the data that you see on the screen here in Stat Edit. So number of hours spent studying is going to be L1, and the score in percent on final exam is going to be L2. So go ahead and enter in that data now. Okay, after your data is entered in, I want you to hit zoom, and then before you hit the number, I want you to look at zoom 9. It says zoom stat. That allows us to see our statistical data that we're entering in. So hit zoom 9, and then you should see a scatter plot. Okay, so if you don't see it and there's an error, there's a couple things that can happen. You have to make sure you don't have anything in your y equals, whether it's y1, y2, whatever. So if you hit y equals and there's an equation or some, I don't know, I've seen stars and asterisks and lines, if you get rid of all of those in your y equals settings. Another mistake I see a lot is your plot's not on. So you have to make sure it's on, or else it won't be able to zoom to this statistical view. Okay, so this is the scatter plot I see on my calculator. So I hope you see the same thing on yours. Alright, so now we're going to find the line of best fit. To do that, you need to hit Stat, and then you're going to go arrow over to Stat Calc. Now, the first thing you need to do is decide what kind of function you think this represents. So, I don't know about you, but for me, I see that it's a linear function, a straight line. So, I'm going to choose Stat Calc number 4, which says LinReg, which stands for linear regression. Alright, so you're going to choose number 4, and you're going to enter all the way down. You might have to hit enter a couple times depending on what type of calculator you have. And then there you see on your screen A and B. Now, on my screen, I see R squared and R. Okay, if you don't see R square and R, we need to turn it on so that you do see it. And then once you turn it on, it'll be on there forever until you turn it off. And we're going to be using it in class anyway, so just leave it on. Okay, so if you need to turn it on, you're going to go to Second Catalog, which is the 0 button. And then I want you to go down to Diagnostic On. So you're going to have to either arrow down, or you can hit the letter D to jump down to D and then arrow down. So you want to see Diagnostic On. Okay, so when the arrow's next to Diagnostic On, I want you to hit Enter. You got to hit Enter one more time and it should say Done. Now go back and do this Stack Calc number 4 and hit Enter until you see your A, B, and C. Or, I'm sorry, A, B, R squared, and R. Alright, so I'm going to record the function. Y equals 4.81 x plus 60.19. Okay, so you might be asking yourself, well, why did she have us turn our diagnostic on to see R squared and R? So R stands for the correlation coefficient. How strong is the data, meaning our plotted points, how strong is that compared to the line, like this red line or blue line now that we put through it? How close is my line to matching up with that data? The closer to 1, the better it is. So R on our screen right now, our R is 0.9456. That's pretty good. So that tells us that we picked a pretty good model, which was linear, to represent the data given to us. Okay, so R squared represents the variation in our data. So R squared is something else that we can use to help us decide if the regression we picked, the model of regression we picked, is close to the data, representing the data well. So you'll actually notice the more we do in class, when we do things other than linear functions like quadratics or log or exponential, those curves actually only give you an R squared. So R squared is actually the value we're going to be looking at. Okay, so now we're going to take our graph and our scatter plot and dissect it a little bit more. So let's say that we had a graph or a scatter plot that looked like this. Okay, let's see if I can make those a little bit thicker. There we go. Okay, so I don't know about you, but this kind of looks linear. Okay, it kind of looks like it could be a positive correlation of linear. So say we picked linear and our line of best fit went through it kind of like this. Alright, so we use a line of best fit because the line of best fit here that we create is what we consider our predicted value. And these dots down here on the scatter plot, these are the actual measured value. Well, we actually took the data. These blue dots are the actual data that represent what we're talking about. So this was the measured data point, and the Y represents predicted. So based off of the trend of our measured value, our data points, we can then create a model that fits it best, whether it be linear or quadratic or cubic or whatever. And then we can make predictions and answer more questions about it based off of the predicted value and the curve of the line that we fit to that data. Okay, so a residual is the distance between the predicted value and the measured value point. Okay, so that's the residual. Okay, so why do we use residuals? Residuals, along with our correlation coefficient, help us determine if the line of best fit, or the model function we choose, our regression model, if we made a good decision or not. So we're going to just work with this data, and then in class we're going to do some more practice with it. But what we do then is we take the difference between the measured value and the predicted value, and we create a residual plot. So it's another plotted graph that will represent our residual, the differences between each of the measured values and the predicted value. So let's do that in the calculator, and then we'll kind of talk a little bit about residuals. So to do that, you now need to go back into second stat plot, which is second y equals, and then you need to hit enter and go back into it. So when we're in it and our plot's on, we want to keep the typograph to still look like a scatter plot. So that's going to stay the same. Then our X list should be L1 right now, and our Y list should read L2. So we want to change that Y list. So go move the blinking cursor down to the Y list. And now we're going to change it. We want it to be L1 and the residual graph. So to get the residual list, you're going to hit second, and you're going to hit stat for a list of all the names of the lists we can put in there. So at first you'll see L1, L2, L3. Now in some calculators, I believe it's number 7. On mine, it's actually all the way down at the bottom. So I want you to pick whichever one says resid. Okay, then you're going to hit enter, and then your Y list should read resid. Okay, so now what I want you to do is I want you to hit zoom 9 again, and now you're going to see a scatter plot, but it's going to look a lot different. Okay, so we should have a similar screen for our residual graph. Now, if you notice with the problem that we gave when we did our scatter plot, we had values that were kind of all over the place. So in the example where I drew the line and had the blue dots above and below the line, that gives us positive and negative numbers, which is why we have this being the y-axis and this is our x-axis. We have positive values and we have negative values. Now, the key to a residual is that the points that you see right here need to look random. If there's a trend, like a linear looking trend, or the dots form a quadratic curve or something, then that indicates that the function that we're choosing, the regression model that we chose for this residual, and in this case it's linear, then that's not a very good one. So in my opinion, this right here is pretty random. They're kind of all over the place. So I would say this is a good representation of our data. We used a linear function, or we chose a linear function. We had a strong R value, and it makes sense logically. Well, the more I study, the better test score I'm going to get. So you can't just rely on one of these things. You can't rely on a residual, the correlation coefficient, the model, the real world analysis of it. You have to put all these things together. And this we're going to do more of, but it kind of gives you a view into what we're going to be working with.